Hello everyone, welcome back. In this video, we are looking at the solution to question 8 on the May-June 2022 CSEC Mathematics Paper 2. It is a linear programming question, and we have a situation here where a rental company has X cars and Y minivans, and the company has at least 8 vehicles altogether. The number of minivans is less than or equal to the number of cars, and the number of cars is no more than 9. We are to write down 3 inequalities from this. And the 3 inequalities that we can write stem from these 3 situations here. The company has at least 8 vehicles altogether. So the first one is x plus y. At least 8 means that we are going to use 8 as a lower number. It's a boundary, a floor, so to speak. So it's greater than or equal to 8. Now the next one says the number of minivans is less than or equal to the number of cars. So minivans is y. So y is less than or equal to the number of cars, which is x, and x, the number of cars, is no more than 9. So x is also less than or equal to 9. Those are the 3 inequalities there. And the next part, a car can carry 4 people and a minivan carries 6 people. And there are at most 60 persons to be taken on the tour. So we're planning for 60 people, which means that we need to write this up as 4x plus 6y is less than or equal to 60. And in writing that up, we can simplify it and get the 2x plus 3y is less than or equal to 30 here. When it says to show it, it's pretty much related to that. So we go through and divide this by 2. And 4x divided by 2 gives us 2x. And 6y divided by 2 gives us 3y. And 60 divided by 2 gives us 30. So there we go. We have shown that this situation coming from that one. And now we need to draw a graph using these inequalities here. So the next part would be to draw your graph. Now using this first inequality here, I'm just going to write them down as 1, 2, 3, and 4. Of course, they are straight lines. So x plus y is greater than or equal to 8, which means that y is greater than or equal to 8 minus x. And there are some easy points that you can put on this. When x is 8, y is 0. When y is 0, x is 8. So we can put in those two very, very easily. 0, 8 and 8, 0, which come from here, and put a straight line through them, just like that. And since we're saying that x plus y is greater than or equal to 8, then what we want to do is to indicate that we are interested in this section of the line, because we're looking for what we call a feasible region. Next inequality, let's look at that one quickly. Y is less than or equal to x. So we're just going to draw the line y equal x. And y equal x, of course, let's pick 2 points. Here we have 4, 4. Let's just mark that one. And 12, 12. Let's mark that one too. And of course, 0, 0. And let's just put a straight line straight through those. Just like that. And it says y is less than or equal to x. So we're dealing with the underside of the line, the less than side. So we are interested in this side of the line. So it's always very important that when you draw these inequalities that you indicate the side that you are interested in, because those sides that you indicate will lead to the feasible region. Next one, x is less than or equal to 9. That's very, very easy to draw in. So let's put in this one. X is less than or equal to 9. So we have a line coming through here. So let's just draw a straight line going through 9. All right. And it's less than or equal to 9. So we are interested in this side of the line. So you can see your feasible region forming here. Now we have one more to draw, and that's this one. 2x plus 3y is less than or equal to 30. And so we can write that as 3y is less than or equal to 30 minus 2x, and then y is less than or equal to 30 minus 2x over 3. And of course, we're going to need some values to draw this. So xy, if x is 0, if x is 0 here, then we are going to get 30 divided by 3, that gives us 10. And let's say x is 6, or let's say x is 9, 2 9 is 18. If x is 9, then we have 30 minus 18. And of course, here we have a 2, we have 12, and 12 divided by 3 gives us 4. So we have those 2 points that we can work with, 0, 10, and 9, 4. Let's fill them in, 0 to 10, and 9 to 4. So we can join those, put a straight line through them, and there we go. Make sure that we cover that. All right. And so since the expression said it's less than or equal to, we are dealing with the underside of the line again. So you're dealing with this side of the line. And hopefully now you can see your feasible region really, really clearly. It's this section that is right here. That section there, that is your feasible region. I'm going to go to another graph that I drew before. So that is a bit bigger, so we can see it more clearly. Here it is, where we have our feasible region. Just going to highlight it there. Exactly there, there. And what the feasible region is that section of your solution, of your graph that contains all the solutions. But when we're doing linear programming, what we look for are the extreme values. So we have some values here. We're going to write them down. Those are the corner points. Those corner points are very, very important. So here we have one. This is 4, 4. Let's just erase that. 4, 4 for this one. That's one possible solution. Here we have 6, 6. That's another possible solution. 8, 0 here. 9, 0 here. And 9, 4 there. And those are all the possible solutions. But every point in this section is a solution. But these are the ones that we're most interested in, because these are the ones that form the boundaries. All right. Now that we have those, we're going to look at what the question says. It says the company charges a minimum. I think I'm missing something here. Yes, I did. Determine the two combinations for the minimum number of cars and vans that can be used to carry exactly 60 people. All right, so we're going to look at this on the other page. Determine two combinations for the minimum number of vans and cars that can be used to carry exactly 60 people. So we need one or two of these combinations that amount to exactly 60, and that relates to this inequality that we wrote down earlier, which says 4x plus 6y is less than or equal to 60. So since we want it to be 60, we're going to say 4x plus 6y equals 60. Now, which of these combinations can work? And by playing around with them, you'll realize that this one and this one are the ones that work. So 4 times 6 plus 6 times 6 gives us 60, because here we have 4 6 is 24 plus 36, and that gives us 60. And the other one, 4 times 9 plus 6 times 4. So here we get 36, plus 24 again, and that gives us 60. So the two combinations of vans and cars that can be used to carry exactly 60 people would be 66 and 94. So let's write it down here, 66 and 94. Remember, the X number is cars and the Y number is minivans. So 6 cars, 6 minivans, or 9 cars and 4 minivans, as the case is. Next part of the question again talks about the company charges $75 to rent a car and $90 to rent a minivan. Show that the minimum rental cost for this tour is $990. This is a kind of not exactly sure what the persons who wrote this question were thinking about, but like I said, every point in this is a solution, and the ones on the extremes are usually the best solutions. What the writers of the question seem that they were intending is to focus on exactly 60 people going on the trip, but the trip did not specify exactly 60 people. It said 60 people or less, which is why these other solutions come into play. But since we need only 60 people, then we're going to look at the two solutions here that carry 60 people exactly. So 4x plus 6y equals 60. Now let's use that to work it out. Well, no, we're going to be needing a different inequality. So let's write it down because we're dealing with the cost right now. And so it's going to be, remember, x is for cars. So it's 75x plus 90 for the minivan. And we're to show that the minimum cost is that. Now remember the 2 points. The 2 points were 66 and 94. And we found those 2 points from here. They were the ones that can carry exactly 60 people. These would give you a less cost than the one than 990, but these do not carry 60 people. Only these two carry 60 people. All right, so what we need to do is substitute. So we say 75 times 6 plus 90 times 6. And that gives us 660. 990 exactly. And the other option, 75 times 9 plus 90 times 4, when we work that out, we end up with $1,035. So for the options that carry exactly 60 people, this one is the cheaper one, the minimum one. And the option, of course, as I said, is 6 cars and 6 minivans. If these were not at play and we weren't dealing with exactly 60 people, then the other solutions, the other extreme points would come into play and we would have had a smaller number. But since it's limited to the 60, then we deal with that. That brings us to the end of the question. Thank you so much for watching. If you found this video useful, then of course, we're asking you please to subscribe as a show of your support. Thank you so much for watching, and the best wishes as you study.